1.5 continued. Yesterday we did the inequalities. Today we're going to do compound inequalities. It's the same. There are two types of compound inequalities. Just like compound sentences, it has something in between them that puts things together. Okay, compound inequalities. The first type is and. Who remembers the second one? Or. Yep, an or problem. An and inequality means that the solution set must satisfy both inequalities. Okay? If it's an or problem, the solution set only works for one of them. When we have an and problem, all of your answers are sandwiched in the middle. Okay? So on our number line, typically we have two numbers, and all our answers are sandwiched between them. Which means our interval notation is sandwiched between two numbers, whether parentheses or brackets or whatever, but it's all in the middle, right? If it's an or problem, it goes in the opposite directions from each other. So it either works on this half or it works on that half. And then we also have two pieces to the interval notation. It starts at negative infinity, goes to our first number with either a parenthesis or a bracket. Does anybody remember what goes in the middle? A U. Remember that? It meant union. And then we start with the next one, whether it's a parenthesis or a bracket, the new number to positive infinity. So if there are two pieces on the graph, there are two pieces on the interval notation. Yes, sir. Well, it depends on what you have. Like, okay, it depends on the sign. I was just kind of giving you guys a general, this is what's going to happen thing. Okay? So, hopefully we remember these. I always used to say to you guys, if it's an or problem, it goes in opposite directions. If it's an and problem, it's sandwiched in the middle, right? Okay. Exactly. So, example number 1. We're going to start with and problems. Okay? An and problem can be written two different ways. I can have it as, let's go, 6 is less than 2x plus 4 less than or equal to 10. So you can see my x is in the middle that I have to solve for. Okay? Or maybe an and problem can be written. So this can be written as two separate pieces. Okay? It can be written as 2x plus 4 is greater than 6 and 2x plus 4 is less than or equal to 10. So if it's written in with a word in the middle, you know it's going to sandwich together. If it's written with or in the middle, you know it's going to go in opposite directions. Right? It never changes. Okay? But I think, knowing you guys like I do, well, I think I do, we're going to do it the first way. We're not going to separate it. We're going to put it together. Okay? So if it is written all together, 6 less than 2x plus 4 less than or equal to 10. To get x by itself, whatever we do to the middle to get x by itself, we have to do to both ends. Okay? Subtract 4 is where we're going to start. If I subtract 4 from the middle, I'm going to subtract 4 from both ends. So I get 2 less than 2x less than or equal to 6. Is my x by itself yet? So now we're going to divide by 2. Again, whatever I do to the middle, I have to do to both ends. Less than or equal to 3. Good. Okay. So now let's put this wonderful thing on the number line. At 1, do I have an open or closed dot? That's open. At 3, do I have an open or closed dot? Closed. And where are my x's? They're all in the middle. See, x says it's greater than 1, which means it goes this way, and x says it's less than 3, which means it goes this way. So that's going to be or. Okay? So then my interval notation, it starts at the open dot, which is a parenthesis, 1 to 3, and this I have a closed dot, so I have a bracket. Perfect. Anywhere from 5 to 14. Yeah. All right, here we go. Example number 2. And do number 2. All right, let's say we have -8 is greater than -6 plus x greater than -16. So I'm going to talk to you about, look at this. Somebody tell me what's wrong with it. Negatives are okay. Yeah, they're both going that way, which is opposite our first one. But look at our numbers. Is -8 smaller or on this side of a number line and -16 is over there? No, we got to make sure that's in the right order. Okay, so I'm just going to put the whole thing and flip it. So I'm going to start here. I have -16. Remember, the point points to the 16, so I have less than x plus -6, or actually let's write it as -6 plus x. Sorry. -6 plus x, and then again, I have the point pointing to that, -8. Is everybody clear how we just flipped that over? Okay, now we're going to go ahead and solve it. How do I go about getting x by itself? Add 6, add 6, add 6. -16 plus 6. -10. Less than, what do I have in the middle? Less than. -2. On my number line, at -10, do I have an open or closed dot? At -2, do I have an open or closed dot? Where are my x's? Yes, it's in between here, right? X is greater than -10, and x is smaller than -2. Interval notation looks just like that. I have a parenthesis for my open dot, -10 to -2 with a parenthesis. Yep, all three of that is the answer. You are correct. All right, so do we have any question on and? All right, let's talk about or. Example number 3. Let's say I have 2x plus 4 less than or equal to -16, or, and an or problem will always write the word or in the middle. Let's say 5x is greater than 20. All right, so on an or problem, we have to solve 2 separate pieces. Everything in an or problem is 2 pieces. Everything. So we have this one first. 2x plus 4 less than or equal to -16. I start by subtracting 4. So I have 2x less than or equal to -20. And then I have to do what? So I have x is less than or equal to negative 10. I heard that. I'm going to go ahead and put that on my number line right now. Negative 10. Is that an open or closed dot? Closed. In which direction does this go? To the left. Exactly. It goes that way. All right, let's do the other piece. I have 5x is greater than 20. Divide both sides by 5. X is greater than 4. So over here I have a 4. Do I have an open or closed dot? And this one goes which way? To the right. Okay, so we had two equations we had to solve. We now have two different pieces on the graph. How many pieces of interval notation will we need? 2, exactly. Here's my first one. It starts at negative infinity, goes to negative 10 with a bracket. Good. Over here, I have open circles, that's a parenthesis, 4 to infinity, and what goes in the middle? Perfect. You guys are awesome. One more example and I'm done, okay? Almost. I have enough for one more example, right? Here we go. Example number 4. All right, example number 4. Let's say I have negative 2x plus 4 is greater than or equal to 10. Or I have 4x plus 1 is greater than or equal to, how about 24? That sounds good. I don't know, something different. They do, but let's see what happens. Or means it should do what? It's going to go in opposite directions. So let's see what happens when we do this. I have negative 2x plus 4 is greater than or equal to 10. Minus the 4, excellent. Negative 2x is greater than or equal to 6. Now we're going to divide by a negative, so what has to happen? Sign's going to flip, right? So I have x is less than or equal to negative 3. All right, I'm going to put that on my number line at negative 3. I have a closed dot, and it goes which way? To the left. Awesome. Okay, second half. Here, I have 4x plus 1 is greater than or equal to 24. I start by subtracting 1. So 4x is greater than or equal to 23. Good. X is greater than or equal to 23 over 4. On my number line at 23 over 4, do I have an open or closed dot? Open, and it goes to the right. So again, two inequalities, two pieces on the graph. How many interval notations? Start with, oh, sorry, it's close, my bad. It's close, my bad. I can make a mistake once in a while. It's okay. All right, here we go. I have negative infinity to negative 3 with a what? Now what? Good. I have a closed dot. 23 over 4 to infinity. Questions? Pretty easy? Go ahead. Go ahead and answer the question. Great question. Great question. Look at our arrow. Where does this arrow start at, Vance? That arrow, negative infinity. That one goes all the way that way. Yeah. Anybody else? Sean. Right after I finish talking.